All right. Looks good to go. So we did a lot of these in class, but some of you weren't in class. So here we go. Use the bar graph on the right to answer 1 through 4. Well, the first thing we're going to want is we're going to want the heights of all these bars to find the total number of spins that were spun on this spinner. So here we have 8, here we have 6, there's 9, there's 11, there's 9 again, and there's 7. So if we add these numbers together, 8 plus 6 plus 9 plus 11 plus 9 plus 7, we get 50. So there's 50 total spins. And we want the relative frequency of spinning an even number. The even numbers are 6. Well, there were 6 2s, there were 11 4s, and there were 7 6s. So just real quick, 6 plus, oops, there's no clear key on this. All right, 6 plus 11 plus 7 gives us 24. So 6 plus 11 plus 7 is 24. And the probability, well, relative frequency, so we're not going to use the symbols. Relative frequency is 24 out of 50. When you divide 24 by 50, I'll show this work. 24 divided by 50 times 100 gives us 48%. Probability of not spinning a 1. Well, the probability of spinning a 1 is 8. So the probability of not spinning a 1 is 50 minus 8, which is 42. So we're looking at 42 out of 50. And 42 divided by 50 times 100 is 84. So the probability of not spinning a 1 is 84%. Probability of spinning a 1 or a 3. Well, 1s are 8 frequency, and 3 has a frequency of 9. So 8 plus 9 is 17. And so our probability is 17 over 50. And so again, then, we've got 17 divided by 50 times 100, and that gives us 34%. The probability of spinning a 1 or a 3 is 34%. Your friend uses the bar graph above to find the experimental probability of spinning a 4. Is your friend correct? So please note, it's experimental probability. It says over here there are 6 possible outcomes. We know that that's not true right off the bat, because up here, the first thing we did was we found out there were 50 spins. So there's not 6 possible outcomes, there's 50 possible outcomes, because there were 50 events that we performed. So the experimental probability is not 1/6. It's instead something very different, but we don't need to know that. We need to know that what our friend did is, my friend found the experimental probability. That's what our friend unfortunately did. And so we'll need to explain it to our friend. Okay, probability of spinning red. Well, there's 6 possible outcomes, and 2 of them are red. So we've got 2 6, which is 1/3, which is 33.3%. Spinning a number less than 7. Well, all of these numbers are less than 7, so we're looking at 6 out of 6, which is 100%. Probability of spinning a 9. Well, none of these numbers are 9s, so that's 0 out of 6, which is 0%. A board game uses a bag of 105 lettered tiles. You randomly choose a tile and then return it to the bag. The table shows the number of vowels and the number of consonants after 50 draws. Predict the number of vowels in the bag. So we want probability of vowels. That's going to be the first thing that we need that's helpful to us. We've got 18 vowels out of 50 draws. So what we can do here, instead of finding the percent, what we can do is we can say, hey, you know what? Here's a proportion of, well, here's a ratio of vowels to draws. Well, if we assume that draws is lettered tiles and that the ratio stays the same, which is a big assumption, but it's one that we have to make if we're going to make a prediction. We're going to go 18 to 50 is some unknown number of vowels to 105. And now we cross multiply. So 18 times 105 gives us 1,890. So we have 50 V equals 1,890. We divide both sides by 50. And so let me go back over here. 1,890 divided by 50 gives us 37.8. Now you can't have 37.8 vowels. So we're going to round this up to 38 vowels. That's our prediction. We could be wrong. But our prediction is reasonable. We used math and we used a reason behind a prediction instead of just gut feeling. So the bar graph shows the results of spinning the spinner below 200 times. Compare the theoretical and experimental probabilities of an event. So spinning a number greater than 4. Well, there's only one number on the spinner that's greater than 4. So we'll find the theoretical probability first. And so it's 1 out of 5, which is 20%. Now, on the other hand, we've got 200 spins and 40 of them are 5s, which means that 40 of them are greater than 4. So the experimental probability is 40 out of 200. So going over to our calculator, 40 divided by 200 gives us 20%. So it says compare. These are the same. Now that's not always going to happen, but it happens here. Should you use theoretical or experimental probability to predict the number of times you will spin a 3 in 10,000 spins? You should use theoretical. And the reason being is that we know the spinner is pretty good because each of these columns is about the same height. So we don't have to worry about the spinner being off. And so you should use theoretical because we do not want to spin 10,000 times. That would be obnoxious. In a game show, a contestant randomly draws a chip from a bag and replaces it. Each chip says either win or lose. The theoretical probability of drawing a chip is 3/10. Winning chip is 3/10. The bag contains 9 winning chips. How many chips are in the bag? All right. So we go 3 over 10 equals 9 over C. So we cross multiply. 3C equals 90. Divide both sides by 3. And C equals 30. So there's 30 chips in the bag. Out of 20 contestants, how many do you expect to draw a winning chip? Well, we'll go 3 over 10 equals x over 20. Cross multiply, 10x equals 60. Divide both sides by 10, and x is 6. We would expect there to be 6 winners. There are 8 females and 10 males in a class. What's a theoretical probability that a random chosen student is female? So because there's 8 females and 10 males, there's 18 students. So we know that 8 out of 18 is the probability of choosing a female. And that's 4 out of 9, which as a percent is 4.4%. 1 week later, there are now 27 students in the class. The theoretical probability that a random student chosen is a female is the same as last week. How many males joined the class? Okay. So listen carefully how we do this. There's an algebraic way of doing this that I want to run to, but I think that what I'm going to do on the video is going to make a little bit more sense. And it's a struggle. So here we go. Here's what we know. We know the probability of females is 4 out of 9. So that means the probability of choosing a male is the remainder, 5 out of 9. And we know that if the probability of randomly choosing a female is the same as last week, the probability of choosing a male is the same as last week. So what we know then is we know that out of these 27, 5/9 of them are males. So if we cross multiply here, we get 9m equals 135. And we divide 9 to both sides, or from both sides. 135 divided by 9 is 15. So we know that there's 15 male students now. But last week we knew that there were 10. So we go 15 minus 10 equals 5 males. For those of you curious, the other way to handle this problem is to go 10 plus m over 27 equals 5/9. This will get you the same answer. You'll just have to cross multiply right at the start there. Okay. The table at the table at the right shows the results of flipping 2 coins 12 times each. What's the experimental probability of flipping 2 tails? 2 tails happens once out of 12. So probability of TT is once out of 12, which just that's 8.3%. Using this probability, how many times can you expect to flip 2 tails in 600 trials? So we're going to use that probability. So 1 out of 12 equals x over 600. So we cross multiply. That's 12x equals 600 divided by 12. So x equals 50 times. The table on the left shows the results of flipping the same 2 coins 100 times. What's the probability of flipping 2 tails? PTT. That's 22 over 100. Well, that's 22%. So if we do 600 trials again, using the probability, how many times can you expect to flip 2 tails in 600 trials? Well, we're going to go 22 over 100 equals x over 600. So that's 100. X equals 132.00. Divide by 100. That gives us 132 times. So Why is it important to use large number of trials when using experimental probability to predict results? By using a large number of trials, we may produce a more accurate result. Okay, review. There's a 95% chance that school will not be canceled tomorrow, so that means that it's likely. Find the annual interest rate. That means we're looking for R. So we've got I equals P RT. We're given 18 months. 18 divided by 12 is 1.5. So we have $26.25, 500 for P. We don't know what R is. We know that T is 1.5. So 26.25. We need 500 times 1.5 gives us 750. Divided by 50. Divided by 750. So I'm going to come back over here to 26.25 divided by 750 gives us 0.035, and then we multiply that by 100. And so that gives us 3.5%. Tell whether x and y are proportional. So we're just going to divide 0.3 by 0.75 and get an answer. We're going to divide 0.6 by 1.5 and get an answer. And we're going to divide 0.9 by 2.25 and get an answer. So let's see what these answers are. 0.3 divided by 0.75. That gives me 0.4. Over here, 0.6 divided by 1.5. Hey, that gives me 0.4. So far, this is looking like these were proportional. One more number, 0.9. Oops. 0.9 divided by 2.25. And that's 0.4. So since these are all the same, yes, this is proportional. All right. So I would like you to make sure you do these last five. These last five are for you to do on your own. But everything else has been done with you or for you. So hopefully you have learned along the way. Thanks. Bye.